We're going to talk today about something called the binomial distribution. Binomial distribution is a nice distribution because everything can be broken down into two values, yes or no, success or failure. So this is a nice distribution to deal with. It's one of the only ones we're going to call by name, and we'll be using this quite extensively. So what is the binomial distribution? Okay, the binomial distribution is something that can come up. It's a distribution of something that has two distinct outcomes. Now, a lot of times you'll look at something and it won't look like a binomial distribution, but if you can label something as success or failure, win or lose, yes or no, you can make it a binomial distribution. So here's the rules, though, is that each trial has only two outcomes. Okay? The outcomes of each trial must be independent of one another. In other words, if I'm going to flip a coin, okay, the second time I flip a coin has nothing to do with the first time I flip a coin. They're independent. And the probability of success must remain the same for each trial. Okay, again, flipping a coin, it's 1/2, either heads or tails, right? So that doesn't change depending on the outcome. Now, let's look at some of these notations. Okay, these are the way we will label things. So PS is the probability of success. PF is the symbol for the probability of failure. You don't use these very often. We're going to use little p for the numerical probability of success and little q for the numerical probability of failure. Q is going to be 1 minus p. See that? So if, for example, if the success, the p is 75% for success, then your failure will be 25%. Okay, n is the number of trials we're going to do. So a binomial distribution is when we're going to flip a coin, say 100 times. Okay, and so that would be like the number of trials. X is the number of successes in n trials. So this is something we're going to run experiments on. All right, so let's look at an example. Your first example is in what ways, what things can we label as binomial? Okay, so let's start with the first one. Okay, if we just want to survey 100 people to see if they like sudsy soap. All right, so we're doing 100 trials, so that doesn't matter. So is it binomial though? Is there success or failure for each trial? So for each person that we ask, their answer is either yes or no. So this could be a binomial distribution. Okay. The next one is asking 1,000 people which brand of cigarettes they smoke. All right, so 1,000 people doesn't matter. We're doing 1,000 different trials, but each time we ask, we're asking something that has a wider range of values. Okay, it's not a yes or no, success or failure. Okay, there could be 20 different answers. So this is not binomial distribution. Okay. So practice problem. This is your practice problem, asking 100 people if they smoke. Pause, answer the question, and then go on. Okay, yes. It is the yes or no question. Okay, example 2. Okay, compute the probability of X successes using the table B in appendix. Okay, so we are going to do these problems. You're going to have either, you can either use a table or a formula. The table, I actually have examples in these notes, so you can just look at them. So this says, and let's look at what each of these numbers mean. Okay, n equals 2 is how many trials we're going to perform. We're going to do an experiment. We're going to perform 2 trials. The probability of success is 30%, and we want 1 success. So what is the probability of 1 success if we run 2 trials and we have a 30% chance of success? So the first thing we have is the formula. I want to show you the formula. It looks meaner than it is. Calculators will do most of the work for you. Okay, so the probability of x is n factorial, okay, over n minus x factorial times x factorial. That formula should look familiar. I'm not going to talk about it on here, but if you can find the one that it looks like, make your life a little bit easier. Okay, times p to the x, okay, so the probability to the x, times q to the n minus x, okay, so the probability of failure to the, for the other values. So if I did it as a formula, 2 factorial is my n value, 2 minus 1 factorial, and minus x, I want 1 trial, times x factorial. And this factorial button, if you forgot, is in your calculator under the probability tab. Okay, times 0.3 to the first power, okay, because 1 is the number of successes I wanted, times 0.7 to the 2 minus 1, which is also 1. I would plug this all into my calculator, and I would end up with 0.42. So this is one way to do it. Now, the problem asks you to actually look it up in Appendix C, so we're going to look in Appendix C. Okay, and this is what Appendix C looks like. Okay, it has our n values along the side, the number of successes next to it. You'll notice that for each, like for n, there's only 0, 1, or 2 successes. If n is 3, it's 0, 1, 2, or 3. Okay, it lists all of the possibilities. So for n of 2, 1 success with a p-value of 3, my probability is 0.42, that exact number of successes will happen. Okay, this table is in the back of your book. It goes, I think, to 20. I can't remember. I have to 8 on here. I don't know if it goes that far. So personally, I prefer to use the formula just because I know I don't have to go look things up. But and the formula will work for any n value. The table only goes up to a certain number. So. Okay, so here's your practice problem. Now it says using the binomial formula. You can use the formula. You can also use a table if you want. All right, I've given you the formula. I've given you access to the table. Table's in the back of your book. You can look it up that way, or you can just scroll back to the page before. And there's your answer. Okay, so there's the formula, and then the answer's right above it. And that's it. I'll see you tomorrow.